the first board we are going to look at, and this is boards that I have in different state of repair. I don't think any of them is fully working, but yeah, there are some slight things with all of them, and most of these boards is boards that I've got. I actually bought a bunch of boards some months ago, and some of these has been repaired, like this one. The 6526 are socketed and they are missing, but this is 250407 board, and it's a C revision of that board. It does not have the new oscillator circuit here, but this has R3 version of the VIC-2 chip. I don't think there is anything much wrong with this, but this will include some solder and stuff. And I'm going to put a number on each board that we are looking into to tell them apart from each other. And I will call this board number 1. And the board should give a picture even though the 6526 are missing, and I can put in some new 6526 if that's the case. But I do think I will just try to power this on and see what's happening. This just gives out a black picture, nothing more. And it's a lot of things that can give a black picture. I do want to measure some voltages though. Just turn it on. Yeah, 597 and 12.2. So the internal regulator is working okay. And if I do measure on top of, this should be 5 volt, 484 from the 5 volt rail. It's a bit low, but it's really not that bad. I will just turn off the power and I will massage the switch a bit. Also the power lead, that used to be some power draw. Check here again, it's working, and it's actually lower, 4.68. Just checking the temperature briefly to see. The 6510 is 31 degrees, PLA is 4, 33, VIC-2 chip is 43. Yeah, I just let the chips heat up a bit and measure them sometimes to see if they act up over time. Yeah, nothing obvious shorted at least. A short on the 5 volt rail can also explain the low voltage I measured on the chip. Yes. So it's time to find out what's going wrong, and on these boards with a MOS PLA like that, we can actually start with the PLA and see if that's wrong. And what the repairs that's done on this board, we have one of the 4066 is actually socketed. And the same with this kernel ROM, and the socket looks a bit crooked and the chip was not completely in the socket. And let's try again. Still nothing, black screen. I start out by removing the SID chip. It's not necessary to boot, and it can actually also cause a black screen if there are some shorts on some data lines or other places. But the same is the same, it's still a black screen, so the fault lies elsewhere. I connect my scope probe and I start probing the address and data lines to see if there are something that does not look right, if there is something that's been dragged either high or low, or there are some pins without activity. And I found this on D1, data bus line 1, and you can see the red ring points out where there is a bus conflict, so that we have to look into. Some of the address lines also looked peculiar. Some of the address lines that connect to the PLA, they normally looks a bit strange. They probably have some capacitance in the load, but the address lines A1, A2 and A6 looked exactly the same, and you can see A1 on the screen here. And there are some kind of conflict here where two items is trying to address something on the bus simultaneously. And as the address bus is controlled either by the WIC chip or the 6510, they could be the culprit, or there are some other circuit that's involved in switching the RAM in and out to do the RAS-CAS conversion and also the decoding of the memory refresh. First I'm going to check out the D1 data line, and I'm going to suspect the memory chip first. But first I solder on this lead so that I can have a good ground connection for my scoop close by the chip. And it's U9 that's the memory chip for data line 1. And here we see the same on U9, that's D1, and you can clearly see the difference to U10, that is the D3 line. Yes, I'm going to prepare to desolder the U9, and I try to keep the chips intact when I do this in videos, mostly because I want to test the chips afterwards to see if my theory was right and that the chip actually was defects, or if I was on a wild goose chase. So I will mark this chip and I will start desoldering it by applying some fresh solder first. Here I use my Hakko FS301 desoldering gun, and it works pretty well, and I do prefer this. I have some other desoldering tools, but this actually works quite well. It has a tendency to clog up when it's a lot of old solder and small holes, but other than that I think it works perfectly. Yeah, here there was some holes that didn't unclog good enough, so I apply some more solder and try to suck out the rest together with that. Some of the pins have some blobs of solder on top of the board, so I'm going to remove these by desoldering braid. And I might have to use some hot air from my hot air desoldering station to actually get this chip out in one piece. Yes, I do think hot air is the way to go here to avoid lifting traces. I normally do this with applying heat on the bottom of the print, but as most of the solder on this chip is beneath the chip itself on the top side, I heat it from the top side, and it melts away quite easily. When I solder in a new socket, I also test the memory chips to see if the chip I desoldered is bad, and as you can see it fails straight away. And I will also test the new chip before I put it in the socket, as is the custom after I discover that there is a lot of fake or bad chips out there. As this is an unused chip, I have to adjust the legs a bit before it fits in the socket. Yeah, then I do a quick test, just connecting the monitor, not the sampling device, and just see if there are any improvement. I do doped it since we also have the trouble with the address lines, and as I suspected, the black screen is still there, but at least from our test we know that the memory chip also was bad, and that fault is at least fixed. I also try with the pole position game cartridge before I try with the dead test cartridge to see if there are any life. But the dead test cartridge is never of any good use if it's the address lines that are stuck, because it can't address the right units in the system. So still a black screen, and then we have to look into what can cause lookups and hangups on the address bus. And even though the screen is black, it still is producing video signal, and I did probe for a video signal and it looks okay, but we are still going to test the VIC2 chip in the SixtyClone board to see if that works, and we might also desolder some of the other chips that's addressing the address line. It's in fact every of the major chips on the system is connected to the address lines, so we will have to desolder more chips eventually to see what's causing this clog up. And I actually changed my mind. I'm going to desolder the PLA at once too, as I already got questions from 4 people why I haven't done that just by talking to them. So that's what we are going to do first, and test it in the SixtyClone together with the VIC-2 chip. Also on this one there are some solder on the top side. I will try to melt it here, but I don't think this will be good enough, so I might have to try with some solder braid and take off the big gunks here. Yes, then I think it will loosen quite okay. Yeah, I don't think we lifted any tracks, and the pads and the holes are clean enough to just solder in a new socket. And then it's chip testing time in our SixtyClone board, and we are replacing the PLA and the VIC-2 chip in here, and just try to power it on and test it. And they were quite okay. The normal startup screen appeared. And at the same time we test the kernel, and I try first with my chip puller, but I couldn't get hold of it, so I have to use a flat screwdriver to pick this out. And since the new chip has been in a socket, it's quite easy to just push it into the new socket. Yeah, but the kernel also worked a charm, so that's going back into the other machine. Then it's back to our original board, and we are going to refit the chips, but first we are going to solder in a new socket for the PLA. And of course there was one hole that was clogged up a bit with solder, so we have to take that out, and then we can solder in the socket. And here I use my normal method with soldering 2 legs, and then I push the socket against the board from the other side and reheat the joint so that the socket will be flush with the board. And now I've decided to desolder also the 2 other ROM chips, the basic ROM and the character ROM, and also the 6510 CPU. And the reason I do this without checking anymore is that I will need these chips to populate some of the other boards that I need to repair. So I do need the chips socketed anyway, and as I said, every major chip here is connected to the address bus. When we have soldered these ones, we are going to do a bit more systematic fault finding if these chips are not the culprits. Yeah, then it's to fit the sockets, and here I run into a small problem as I was out of 24 pin sockets, so I do have to cut up a 28 pin socket to fit the character room. Yeah, and we are now packing out the SixtyClone again to test the CPU, the basic ROM and the character ROM. Then we have tested all the major chips that's connected to the address bus. And then we are ready to test the remaining chips, and they works. They booted perfectly, so we do know that all the major chips are okay, so the fault will lie in some of the TTL or control logic chips. Missing CAA 6526 chip should not give a black screen, but I'm going to fit these anyway. They need to be tested, so we can do that straight away without problems. But as expected, still a black screen. So now we will start looking into the control logic that can lock up the address bus. Yes, now we're going to look into the address bus of the C64, and this is schematics that I've downloaded from the simmers.net. And most of the C64s are similar when it comes to this decoding. There are only some small differences. But as I said, there are two chips that simultaneously controls the address bus. And some of the chips are just consumers of the bus. The ROM chips over here, sorry, I should do like this. The ROM chips is just connected to the bus as consumers. It means that they are connected to the address bus and they're not feeding anything back. But of course they can consume so much power or have a short on the bus that will affect what's going on. And the same can be said about the PLA. And also about the 6526 chips. They're connected to the A1 to the A3 on the bus. So what controls the address bus is the VIC2 chip and the 6510 chip. The reason why the VIC2 chip is handling the bus is that it needs access to the bus to do the refresh cycles on the DRAM. And the logic that handles this is actually the chips over here, the 74LS257 chips. And the U13 chip was changed on this machine. It did not stand in a socket, and the soldering and the work that was done there looked really, really bad. And we do probably remember from the beginning of the video when I did the scope pictures, I did trace a fault to A1, A2 and A6, and they're spread over two of these chips, and this chip was actually changed. So I do think that this chip is actually working, so I have no good explanation why this chip should draw something of the bus or make a short on the bus. And the 74LS257 chips are multiplexed chips. So they either gives the control for this to the VIC2 chip, or they give the control to the 6510 chip. And to three-state this bus for other purposes, you have the 74LS373. But when we measured this out of the CPU. And the CPU, as we can see here, is connected first to this bus, and they have the parallel connections here, and from out of this bus springs the A0 to A15 that goes otherwise to the schematic here. So we have desoldered these chips, and these chips was never connected when we did the first test. So we do know that the bus was okay when these chips both was connected and when they was disconnected. And we of course tested these chips. But what we have not tested and that have a direct connection to the address bus is these two chips. So I will now desolder both these chips to see what's happening. I forgot to mention that the control of the bus is actually decided by this signal here that comes out of the VIC2 chip, and that signal is called the Aec signal. And the Aec signal, you can see, is connected to all this logic that actually demultiplexes or three-states this bus. And they also have here the inverted Aec that also goes on to control some other things. And you have the combined Aec that goes over here. And this is actually what goes into the 6510 chip over here. You have the combined Aec. So this is what we will look for, and I do think we just start with desoldering and cleaning up around these chips here and see what we can find. So here you can actually see all the solder blobs that are on this, and I'm going to take this away from that side first with some solder wick, and then I used the desoldering gun on the other side afterwards. I do think it's wise to remove the solder here first, because otherwise it will get sucked into the board from the other side, and it's lots and lots of solder that's blobbed onto this. Normally I'd apply some fresh solder, but this one already has lots and lots of solder, so I'm just going to desolder it. And here I actually managed to lift off a pad, but I do suspect that this actually was an issue before I desoldered this, because I didn't use any force and I had enough heat for it to just slide out of this, but it didn't. Yeah, here I just used the legs of a diode and a very small piece of heat shrink tube to make the bridge for the missing pad. It's very easily accessible because the VI is just next to the pin. You just have to cross over one trace. Yes, then I have soldered the sockets, and I've also put on the missing lead here, and I do think that this actually is the source of our faults. And one of the fault was, of course, this memory chip that was bad. Before we can test this, I need to put in some new chips, and here I'm using the 257HC, and this is HC, not HCT. So this is CMOS chips. They have a very low fan out, but I do think that these memory chips don't draw much on the address lines, and they're also pulled back by these 33 ohm resistor networks that's here. So I do think that, this will work. I never tried this HC chips here. If this not working, we are going to try something else. But what we actually done now on this board is that we have identified that all the data lanes are working and that the address lanes are also working as they should. Except that A6 and A7 was a bit suspect on when we measured this on the 6510 chip. And I do think that the address shifting on these ones was the culprit. But it's one way to find out. Let's test. Yes, and we have picture, and it looks really nice and shiny. So what I will do with this, I will put back the SID chip, and I also will do a test with the test harness to see that this actually works. And we will do some cleanup of this board. And maybe we will take out some of these chips and use them when we test another board later on, because I do lack VIC chips. And I do lack 6526 and also some of the other chips to test everything I have on my table now. And to make this VIC chip last longer, I put on a heatsink, and I will do that on this PLA2 to keep them cold. We will use those chips throughout the testing. So that was this for this board. I do think that this is fully working, but we will do a test with the test harness first. And turn on. Yeah, now I'm testing without the SID chip, of course. They do say keyboard and console port bad, and that means we have to check out these CAA chips. And the first thing I can do is just swap them around to see. And I'm just going to turn this off now. And if we do test with these swept around and the fault does not move to another message, there might be some fault. This is also sockets that was put in by the previous repair attempt on this board, and it was kind of butchery work, but let's see when we run the test again. And I also plug in the SID chip. And I'm speeding up the test a bit. I actually don't have a speaker plugged in here, but I do capture audio. But here you can see all kinds of things are bad. And now they say that both the 6526s are bad. And this is actually 6526s I bought of eBay a while back. And I don't have any other spares here just now. So what do I do with that? I can take the ones from my working C64, or I can find some other solution. Yeah, it just says the same again. Both 6526 are bad. The first thing I will do is actually to take these chips and run them in my working C64 to check if there is anything bad with soldering or these sockets. The butch job that was done here, and there was some bad soldering here, is not very good, I think. The SID is working okay. I didn't hear much of the filter sound, but I do think that's okay. So I'm going to remove these two from this board, and we are going to test them with the test harness in the working C64 SixtyClone board. And to do that we need to remove all the dongles for the test harness. And the test is running. And at first sight the 6526, both of them seems okay. We have to see when they've finished all the tests. Okay, here it comes: cassette, console, control port, interrupt test bad. The interrupt is probably caused by the timer circuit in the 6526, so both of them come out as bad here. But I do know what one of the faults are. Of course, I have not put in the cassette interface. That's my bad. But actually it also stated that the SID was bad, and that I got once yesterday too, but I do think that the bad SID is linked to one of these being bad, because they link the signals to the paddles through here. But yeah, now interrupt is okay, and keyboard and control port is bad, and now it just states that the SID is bad, and that can be due to the test harness. Okay, it's the keyboard bad. If we take this one, and replace this with yes, and there we can see that it runs through the whole test with one of the CA chips. And I will now try to change the one that did not work and try it one more time. And sadly I lost the screen capture footage from the C64 screen, but this test showed U2 bad. So we know that U2 is a faulty chip so we won't test that further, and we just write it off as a loss, even though I bought it just some months ago of eBay. Earlier in this video I showed this picture, and this was after testing the 74-257 ships. And we did conclude that this ship was bad, and that this ship actually was okay, even though it was soldered in a very strange way with a lot and lots of solder blobs on the top side of the print. And I failed to see why this should give any fault on the A6 line, but the test after we finished this repair was that the A6 line also was working okay. And after looking more into this, I think I have found an explanation. And sorry for the bad picture quality, but this is actually the best I have of these prior to us doing any work on this board. And as you can see around here, it's a lot of heavy soldering on these legs. And this actually was the lifted trace that we had. And if you see between here, you can see that there are some traces of something here. And I do wonder if these legs was not shorted until we started cleaning this and desoldered this ship. That can explain why we had trouble with the A6 line, because pin 3 and pin 4 is actually one of the inputs and one of the outputs, the input or one of the outputs for the A6 line. So a short between this would mean that the line was not three-stated. So I do think we do have a trace of something in here that made a short on this board, and that's why we had the trouble with the A6 line. So that's at least the only explanation I have for this. But this sorted out of itself when we did the cleanup on top of this with soldering braid before we desoldered this ship. And this is also the main reason I want to keep the ships when I desolder the ships. Is this the exact fault? And if you just cut the legs or do some other damaging to the ship when you desolder it, you don't have the option to check if your theory was right or it's just a coincidence that anything is working afterwards. Yes, then we have this board again on the bench, and I have one of the original Moose ships from the SixtyClone, and I have the one that tested okay in this, and I'm going to do a new test on this to see, but I do think I will do something about this socket with all the bad soldering anyway. But let's just run through a quick test and see. When you are just testing single components, it would be a good idea just to could skip some of the tests that you already have tested several times when you do this diagnosis. Yes, now it actually tests okay. So then we have one fully working Commodore 64 250407 board, but I will have to take some of the chips out of here to use in some of the other boards that I'm going to repair. But at least I know that this board is fully functioning. But I will clean up some of the solder underneath here anyway and do a new test. Yeah, and just a quick note to my future self that this board was fixed and that it's okay. Yeah, so that's about it for this video about repairing this board. And this is the number 1 board. And I actually do have a large pile of boards that we are going to look into. And this was the start, and this board is now fully populated and working, but we are going to pull some of these ships from this board to fix the other boards. I don't have access to enough spare parts at the moment to populate every board, but I do plan to make the boards themselves usable. So if I want to sell them on, if I give them on to someone, if I need a board, I do know that the boards themselves are fully repaired and I can just populate them with the ships. And that's also the reason why I didn't bother to do more fault finding on board on this. I just wanted a board with a large number of sockets so that it was easy to pull the parts away from this board. I think the next board we are going to work into is this board of similar age, and as you can see, it's missing both the SID, the PLA, and the 6510 chip. And I do have this board here that's in even worse condition. It also lacks the VIC-2 chip. And I do have more boards that are even worse than that. And that means that I need to be able to pull the ships. So I hope you enjoyed the experience. The filming of repair videos is a really hard process to make a good video about, because the fault finding, you do have some expertise, you do have some hunch of what's wrong. And to make the structure of a good fault finding video, you have to mix some theory and you have to mix some of your thoughts into the process and do some extra measurements. And the hardest part for me is to mix in the measurement parts, because you have to be able to mix the different sources on the go when you mix the video. And as my setup is right now, it's from several different sources. So please leave some feedback to tell me what you think and what can be done better in these videos, because as I said, this is just the first in a series of fault finding videos, and I have at least 10 of these coming up. And if people bother to watch them, I will do them now during January, February and March. Otherwise I will take them more on the go throughout the year. So thanks for watching. Please hit like and subscribe if you want to be notified when we post new videos. A like is also the best way to spread the message on YouTube. So until next time.